again. Welcome to Unit 7, Lesson 2. So in this lesson, we'll extend what we learned about finding the probability of simple events, and we will be comparing the difference between theoretical probability and experimental probability. So let's first focus on what we mean when we say that. When we talk about theoretical probability, that is exactly what we did in the previous lesson. We were basing our answers on just the math. So with theoretical probability, you're still looking at the number of favorable or desired outcomes over the total number of possible outcomes. You're not actually carrying out the experiment. So you're not spinning the spinner or rolling the die or flipping the coin. You're not actually doing those things. You're just basing your answer on the math, on the sheer number of possible outcomes and the sheer number of favorable outcomes. You're not actually carrying out the experiment and getting data. So theoretical probability is exactly what it sounds like. It's just in theory. It's just based on the math. And we all know that just because it's what the theoretical probability says, that doesn't mean that's what will happen. For example, theoretically, the probability that I would roll a 2 on a die is 1 out of 6 because there's 1, 2 out of 6 possible outcomes. But I know that if I roll a die 6 times, there's no guarantee that I'll roll a 2 one of those times. I might not ever roll a 2. I could possibly roll all 2s. Anything could happen. So when we talk about theoretical probability, we're not saying that's what did happen or even that's what will happen. We're just saying this is what the math says is most likely. Then we have experimental probability. With experimental probability, we're looking at actual data from the experiment being carried out, and we're using that data to make a prediction. So in this case, you might think about a batting average in baseball. So if someone's batting 300, that means they get a hit about 3 out of every 10 at-bats. But we know that that doesn't mean if they go to bat 10 times that they're going to get 3 hits. It just means based on what they've done so far, here's what we expect. So that is experimental probability, where you're basing your answer on actually doing the experiment. Theoretical and experimental probability won't always line up, especially if you don't repeat the experiment lots of times. Now, the more times you repeat the experiment, the more it should match up with the theoretical probability, because the more times you repeat an experiment, the more reliable it is. Just like in science, we don't do an experiment one time and then just assume that our results are always truth. We have to carry out an experiment several times to know that our results are reliable. So if you look in this table, it shows heads and tails. Now we know that if we flip a coin, 50% chance of heads and 50% chance of tails. So we expect to get heads half the time and tails half the time. That doesn't mean that's what would happen. And you can see, in fact, in this table that when this person carried out the experiment, so they flipped a coin 20 times, they got 13 heads and 7 tails. We would expect from the theoretical probability that they would get 10 heads and 10 tails, half and half. Again, doesn't mean that's what would happen. It doesn't mean they flipped their coin incorrectly since they got 13 and 7. It just means that when you actually carry out the experiment, you're not necessarily going to get what the math says that you can expect. That's experimental probability. So you can think of experimental probability as the probability determined from the results of an experiment. It is based on what actually happened instead of what you were expecting to happen. So let's jump in here and look at some examples. So I'm looking at the spinner, and it says that the spinner has 8 congruent sections. In other words, each section takes up the same amount of space on the spinner. What is the theoretical probability of spinning a light gray section? So the probability of light gray. So our bottom number, again, will be the total number of sections. There are 8. And then the number that are light gray. 1, 2, 3, 4. So you have a 4 out of 8 chance, theoretically, of spinning light gray. That simplifies to 1 out of 2. Or we could say 50%. We could even just put it as a decimal. Is 5/10. All of those, so 1/2, 5/10, 50%, those are all talking about the same value. Those are all the probability, the theoretical probability that we would spin a light gray section on that spinner. If the spinner is spun 150 times, What is a reasonable prediction for the number of times the arrow will land on a light gray section? Again, we're not actually spinning it 150 times. It says if. Well, we know that the probability of getting light gray is 1 out of 2. 1 out of 2. This is saying, well, what if we spin 150 times? This is going to be a proportional relationship. Probability is very rooted in proportional relationships. So what we're saying here is, well, if I would get light gray 1 out of 2 times, then what can I expect to get out of 150 times? So I know that 1 times 150 is 150, and then 150 divided by 2. Because again, we expect to get light gray half of the time. So we're basically looking for half of 150, which is 75. So we would expect to get light gray 75 times. Now, does that mean we would get light gray 75 times? Not necessarily. We could get light gray any number of times out of those 150 spins. But theoretically, based on the math, we expect to get light gray 75 times, half the time. Okay, the next one has actual data. So we actually carried out the experiment. It says Amy spun the spinner 40 times, so that's her total spins, and got the following results: 11 white, 13 black, and 16 light gray. Now it says based on her results, that means experimental probability. We're going to base our answer on what happened when she spun the spinner. What is the experimental probability of spinning a light gray? So probability again of light gray, but this time we're basing our answer on her actual experiment. So out of 40 spins, she got light gray 16 times. That will simplify to 8 over 20, which will simplify 4 we're going to 8 twice, 4 we're going to 25 times. So the experimental probability of getting light gray based on Amy's experiment is 2 out of 5, or we could call that 4/10 or 40%. Now you'll notice that doesn't match the theoretical probability. Our theoretical probability of getting light gray was 50% or 1/2. That doesn't mean that Amy did anything wrong when she was spinning the spinner. That's just what happens. Just because the theoretical probability says one thing doesn't mean that's what will actually happen when you carry out the experiment. Next example. A bag contains 5 blue tiles, 3 red tiles, 4 yellow tiles, 2 white tiles, and 1 purple tile. If you randomly select a tile from the bag, what is the theoretical probability that you will select a yellow or a purple? So we're not actually drawing tiles. It says theoretical probability, so based completely on the math. So if I put all these tiles together for a total, 5 plus 3 is 8, plus 4 is 12, plus 2 is 14, plus 1 is 15. There are 15 total tiles in the bag. We want the theoretical probability of selecting yellow or purple. There are 4 yellow and 1 purple. So the probability of getting yellow or purple well, the total number was 15. 4 yellow and 1 purple, so that's 5. So the probability of getting a yellow or purple is 5 out of 15, which simplifies to 1 out of 3, which would be 0.3 repeating, or 33.33%. I could express the probability in any one of those forms. Again, that was theoretical. We didn't actually draw any of those tiles out of a bag. We're saying just based on the math, based on the number of tiles that are in the bag and the number of each color, there's a 1 out of 3 probability that you would select yellow or purple. Then it says Jamie randomly drew a tile from the bag 20 times. So there's her total draws, replacing the tile after each draw. In other words, she drew a tile out, put it back, drew another one out, put it back. She drew 3 blues, 4 reds, 6 yellows, 4 whites, and 3 purples. What is the experimental probability of drawing a yellow or purple tile? Since it says experimental, that means we're going to base it on the results that Jamie got. We're not going to base it on just the math, on just what the numbers say. We're going to base it on what Jamie got, which means it may or may not match what we expect. So again, We're doing probability of yellow or purple. And it says that she drew 20, and then she got 6 yellow and 3 purple. That's 9. So 9 out of 20. If I want to write that as a decimal, so 9 divided by 20 is 45 hundredths. Or we could call that 45%. So if we want to compare that to the theoretical probability, theoretically we said she had a 1 in 3 chance of getting a yellow or purple, or 33 1/3%. Based on Jamie's experiment, there was a 9 out of 20 or a 45% chance of getting a yellow or a purple. Again, doesn't mean that Jamie cheated or did anything wrong. It's just that we based that result on someone actually carrying out the experiment. Doesn't mean you're going to get exactly what you would expect. She actually got yellow or purple more often than you would expect based on the numbers. That's okay. It just means that's what happened. Now, we would expect if you carried out that experiment more times, so 40 times or 100 times or 1,000 times, we would expect that experimental probability to draw closer and closer to the theoretical probability the more times you carry out the experiment. Okay, next one. Georgia works at a yogurt store. Out of the last 30 customers, 12 ordered a medium yogurt cup. Based on this, what is the probability that the next customer will not order a medium yogurt cup? Again, not order. So we're talking about a complement here, the complement, the not ordering. So if 12 out of 30 ordered a medium yogurt cup, then the ones who did not order a medium yogurt cup would be 30 minus those 12. So 18 did not order a medium yogurt cup, and that was out of the last 30. So based on that, the probability that the next customer will not order a medium yogurt cup is 18 out of 30. We can simplify that. 6 will go into 18 3 times. 6 will go into 30 5 times. So we could call that 6/10 or 60%. So there's a 3 out of 5 probability that the next customer would not order a medium yogurt cup, or we could call that 6/10 or 60%. Now, that also means that the probability that the next person will order a medium yogurt cup, if 3 out of 5 is not, then 2 out of 5 will be the probability that the next person will order a medium yogurt cup, because the 2 have to add together to equal 1, and 3 out of 5 plus 2 out of 5 equals 1, or 60% plus 40% equals 100%. Remember, the complement and then the probability of it happening and the probability of it not happening should add up to 1 or 100%. Next example, a number cube with faces numbered 1 through 6 was rolled 30 times. The results were 6 1s, 5 2s, 2 3s, 8 4s, 5 5s, and 4 6s. Based on these results, what is the experimental probability that the next time the cube is rolled, it will land with a 1 or a 4 showing on the top face? Again, experimental probability. We have actual data up here. Okay, actual data. So if we're going to base it on the actual data, the probability of a 1 or a 4, well, the total rolls was 30. And we want 1s or 4s. We got 6 1s and 8 4s. So 6 plus 8 is 14. So based on the data, there's a 14 out of 30 chance of getting a 1 or a 4. That will simplify to 7 out of 15. I can write that as a decimal. So 7 divided by 15. 15 will go into 76 times. Not 6 times. Let's go 4 times. And that is 60. Drop a 0. And 6 times would be 90. And that's going to repeat. So we could say about 47%. So based on his experiment, we got a one or a 4, about 47% of the time. Now let's think about how that compares to the theoretical probability. There's 1 1 on a die and 1 4. So theoretically, that would be 2 out of 6, which is 1 out of 3. So about 33.33%. So we actually got a 1 or a 4 more times than you would expect. But again, we were asked for experimental probability, so that's based on the data. Last one, Alex flipped a coin 60 times and got 37 heads and 23 tails. Now we know that theoretically, if you flip a coin 60 times, we expect 30 heads, 30 tails, because 50% chance of getting either one. But again, doesn't mean that's what will actually happen. Here we have actual data. How does the experimental probability of the coin landing on heads compare to the theoretical probability of the coin landing on heads? So let's look at the experimental probability first. So the experimental probability of heads. And it says that he flipped the coin and got 37 heads out of 60. And we could see that as a decimal or a percent. So 37 divided by 60. And that would be 360. 61 to 101, so about 61%. So he got heads about 61% of the time with experimental probability. Now, if I want to talk about theoretical, the probability of getting heads, sorry about that, is 1 out of 2, which is 50%. So we would say he actually got heads on the coin way more than what you would expect based on the theoretical probability. And that's okay. That doesn't mean he flipped his coin incorrectly or that he did anything wrong. That's going to happen. When you carry out an experiment, you might not get what the theoretical probability says we expect to happen. Again, theoretical probability is based completely on the math, and experimental probability is based on actually carrying out the experiment. So if you're given data, you're given actual information from the experiment being carried out, then you're going to find experimental probability. Theoretical is based solely on the math, not actually carrying out the experiment. That's it for Unit 7, Lesson 2. If you have questions or want to see more examples, please let me know. If you're ready for the skill check, I'll open that up for you. See you later. Have a great day.